You can think of data visualization as having three main steps. In the first step, you need to wrangle and clean your data to make it ready for visualization. In the second step, you need to pick the right kind of visualization. And in the final step, you write the code for that visualization. In this course, we're going to spend a lot of time thinking about the first and the third steps, but in this particular lesson, I want to focus on that crucial middle step of picking the right kind of visualization. So let's see how to do this. Let's get started. So how do you go about getting ideas for your plots or for your visualizations? There are a few ways that I go about this. One of the most popular ways for me is I just Google search similar plots. So as an example, if I wanted to make a plot of revenue and costs per quarter, I would just search that on Google, go to images, and look for some of my favorite looking images, and then I would try to reproduce that in my own code. Another thing you could try to get ideas, especially for simple plots, is just to ask an LLM like ChatGPT, for example. Here's an example. I gave ChatGPT this sample dataset here, which has month, revenue, and costs, and I ask it, what are some ways I might plot this data? And importantly, I ask it to use Code Interpreter. Code Interpreter is the tool that allows ChatGPT to run Python, so it can actually make some example plots. And indeed, it went ahead and did all of this, and it gave me this example plot, which looks pretty good. And then I can take that and translate that to whatever plotting library I use. And the final way to ideate around your visualization style is to look through a taxonomy chart, and that's actually going to be the focus of this video. Now, taxonomy charts have pros and cons. One of the cons is it's hard to strike a balance between a taxonomy chart that isn't too confusing or that isn't too limiting. It's really difficult to fit all visualization styles into a single flowchart or a single decision tree. All of that said, however, especially for beginners, such taxonomy charts are quite useful. So in this lesson, we're going to go ahead and create a very simple but very limited data Viz taxonomy using an example dataset. And the dataset we're going to use is the tips dataset, which I think you have seen already. It comes built into the Plotly library, and it has about 240 rows and a number of columns. I've subsetted the columns just to these 4 columns here. And each row here represents a specific customer that gave a waiter a tip. So I think this is a real data set that a waiter recorded somewhere in the US. And the total bill column is how much that customer paid. The tip column is how much of a tip they gave. Then you have their sex, and then you have the day of the week that they came to the restaurant. And I think in this data set, there are only 4 days of the week. So now let's think about what sorts of questions can be answered with this data. What sort of questions may you want to ask about this data set? And then we'll think about the kinds of visualizations we can create to answer those questions. Let's start with single variable or univariate questions. These are going to be questions about a specific column, a specific variable. And then we'll start with the numeric columns. Hopefully you can identify which of these are numeric columns. So we may ask, for example, what is the distribution of tips? We may want to understand what is an average tip, what is the maximum tip, what's the minimum tip, and so on. And you can pause the video and guess what the second major univariate numeric question we can ask about this data set will be. Now, how about the categorical variables? We could ask something like this. Are there more male or female diners? So we'd be using this column. And again, you can pause the video and guess what the second major categorical univariate question we can ask is. Now let's move over to the bivariate or two-variable questions that we can ask. We'll consider first the numeric versus numeric. So comparing these numeric columns, we may simply ask, does the tip amount go up with the bill amount? So do higher tips correlate with higher bills? The answer obviously should be yes, but we may want a visualization to confirm this. And then for categorical numeric, we could ask, which sex has higher bills? So which sex tends to pay higher bills? and also maybe which sex tips more. And you can guess what the other pairings would be between categorical and numeric. What other kinds of questions could we ask? And finally, for categorical, so sex and day, we could ask, how does the sex ratio differ by day of the week? So maybe men tend to come more on Thursday than Saturday or something like that. That's something that we could visualize with a plot. So now we're going to take these 5 questions, the univariate numeric one, the univariate categorical one, the bivariate numeric versus numeric one, the bivariate categorical versus numeric one, and finally, the bivariate categorical versus categorical one. And we're going to build a simple taxonomy of the kinds of plots that we need to visualize each of these 5 kinds of relationships. So let's look at the first one. What is the distribution of tips? Now, at each stage of this, I want you to pause the video and think about how you would visualize this data. So how would you visualize the distribution of tips? Well, like I said, we're creating here a one variable numeric visualization. And the major visualization styles we can use are histograms and also violin plots or box plots or jitter plots, which are all very similar. Let's think about the histogram first. So in the histogram, each of these little bars we can see here represents the count of the people that gave a specific tip range. So maybe this bar represents the people that tipped between, say, 2 and 2.5, and the next bar represents people that tip between 2.5 and 3, and so on and so forth. We can visualize the same data in this other way. So here I have 3 plots all on the same figure, and let's go through them one by one. First of all, what's a jitter plot? For a jitter plot, we just have a single point here. Each point represents one of the customers, and so we can easily see the exact amount that they tipped. So this customer tipped 10. This customer tipped 9, and so on and so forth. It's called a jitter plot because the plotting library adds some random jitter, some random variation in the position along the y-axis, because that allows us to see most of the points. Now let's consider the box plot. Hopefully you remember what a box plot is from your high school statistics class. So the box plot is this little box here, and it has a whisker as well. So it's sometimes called a box and whisker plot. And the whiskers here, which start here and end over there, indicate the general range of most of the points, and then typically outliers are represented by external dots. And then this middle line in the center of the box is the median, and this line that starts the box over here is the 25th percentile, and the one that ends the box is the 75th percentile. So that is the box plot. And what is a violin plot? A violin plot is when you combine the box plot with a kind of density chart, and this density chart is kind of a smoothed out histogram. So imagine if you took this histogram and you just smoothed it out a little bit, and then you mirror whatever shows above the axis also below the axis, you would end up with this kind of density diagram. And when you put a box inside of the density diagram so you can easily identify some key points, then we call this a violin plot, because it looks kind of like a violin. Okay, so those are the major plot styles for a one variable numeric chart. How about a one variable categorical chart, like the question, are there more male or female diners? So pause the video and think about how you would visualize this. So typically for such one variable categorical plots, we visualize them simply with bar charts. So on the x-axis you have female and male, and we have the count of the total number of women and the total number of men. You could also visualize this with a pie chart, but you should only use a pie chart if you have a small number of categories, as we do in this case. So next, let's think about the two variable questions. We'll consider first the numeric versus numeric plots. For numeric versus numeric, we had the question, does the tip amount go up with the bill amount? So pause the video and think about how you would visualize this. The most common plot style for this is going to be a scatter plot. So here on the x-axis, you can see the total bill that the person paid, and on the y-axis, you can see their tip amount. And as you can see, generally, the higher the total bill, the higher the tip. So if we take someone like this person who tipped 10, we can see that they paid about 50 or 49. So that tip amount kind of makes sense given how much they spent on the meal. Now for the numeric versus categorical type questions, we wanted to answer the question, which sex tips more? Again, pause the video and think about how you would visualize this. So typically for such a chart, you'd either use something like a grouped histogram or a grouped violin or box or jitter plot. And notice that what we're doing here in this numeric versus categorical is just taking the univariate numeric type charts and then grouping them by color or by position so that we can tell the difference between the two different distributions. So in this grouped histogram, to interpret this, you can imagine that there are two different histograms, but one of them is a little bit transparent, or both of them are a little bit transparent. So if we wanted to count the number of men, for example, who tipped in this range, so maybe this is, I think, 2 to 2.5, we can see the number is around 37. And the number of women who tipped in that range is this lighter yellow, which is behind the blue, and that's about 17. And it's a bit difficult to answer the question, which sex tips more based on this particular plot. It may be a bit easier with this plot. So in the grouped violin or box or jitter plot, we can see that there is significant overlap in the tip amounts for women and for men. But from the box plot, you may be able to tell that the median for men is a little bit higher than the median for women. And a final visualization style you may use for numeric versus categorical data is something like a bar chart. But in that case, you would need to first summarize the data. So you would first calculate maybe the average female tip and maybe the average male tip, and then you will plot just those points. Or you could also plot the median. So you could plot either the mean maybe or the median tip. In this case, I've also added this standard deviation bar. So from here, perhaps it's easiest to answer the question that men seem to tip on average more than women. But of course, this is one of the problems with summary statistics, is that they're hiding a lot of variation. So for the most part, the tip amounts are very similar. There's a lot of overlap, as you can see, between the tip amounts for men and women. But only when you summarize it are you able to get flashy statistics like men tip on average 13% more than women, and then you get some fancy news coverage based on that. But if you look at the actual raw data, there isn't that much difference. Now, finally, let's think about the categorical versus categorical type plots. So for this, we have the question, how does sex ratio differ by day of week? So again, pause the video and think about how you would visualize this. So typically for this kind of plot, we're simply going to take a bar chart and add another level of categorization to it and create a stacked bar chart. So now on this x-axis, instead of sex, I've put now the day of the week. And then on the color axis, we have the sex, male or female. Instead of stacking them on top of each other like that, we could also group them. So this is called a grouped bar chart or a clustered bar chart. And finally, we could normalize it to create a percent stacked bar chart. Now, I recommend that you pause the video and make sure you understand what each of these three plot styles are showing. Well, the first thing I noticed is that I forgot to sort the days, so you can just ignore the unsorted days. But let's think about what the plots are showing. So for the stacked bar chart, you may say, for example, let's consider the women. There were about maybe 19 women that came on Sunday, so that's this section of the bar. And then the number of men that came on Sunday is not 78 or whatever that is there. It's going to be 78 minus this 19. So the green here represents men, but because it's stacked on top of women, it's a bit hard to read the exact amount for just the men. On the other hand, the grouped bar chart makes it easier to read the specific amount per sex. So for example, we can easily see that about 19 women came on Sunday, and maybe about 58 or 57 men came also on Sunday. Now, the percent stacked bar chart is the one that most directly answers this question, how does sex ratio differ by day of the week? What it does is it takes this stacked bar chart and normalizes every bar to 100%. So this Friday bar, Friday doesn't seem to be a popular day for some reason in this restaurant. And so it's a bit hard to compare the proportions of men and women in this small bar here. And so it just inflates that up to 100%. So we can focus on the proportions of men to women. And based on this, it's a bit easier to see which days have higher proportions of men and vice versa. And that concludes our introduction to this simple taxonomy. Although it is simple, I will say it covers about 70% of the kinds of visualizations you may need to do. So now let's do some practice to see if you've built good intuitions. So here I have another data set with 5 columns. So in this data set, each row represents a country, and then we have the country's continent, their life expectancy in years, their GDP per capita, which is basically how much money the country makes per year, and then the income group, which is based on the GDP per capita. And we're going to ask a few questions about this data set, and I want you to think through how many variables we're using in each case, whether it's numeric versus numeric or just categorical, and then think about how you would plot that data. So the first question is, how does GDP per capita vary across the different continents? So pause the video and think about how you would do this. Well, GDP per capita is a numeric column, and the continent column is a categorical column. So we're in this numeric versus categorical section. So we would probably want to do one of these. And here's a plot that I made. So this is a grouped violin chart that also has jitter points. And based on this, you can see maybe that the median is highest for Europe, and Africa has the lowest median. Asia seems to have a pretty wide spread of GDP per capita. Oceania looks like it has a high median, but this is why adding a jitter plot is very good, because we see there's actually only 2 points. So only 2 countries from Oceania are in this data set. And that is hidden if you look only at the box plot or at the density plot. So if you add the points, then it's easy to see the number of countries that this data is coming from. All right, let's look at the second one. Is there a relationship between a country's GDP per capita and life expectancy? Pause the video, think about how you would visualize this. So GDP per capita is numeric, life expectancy is numeric, so probably we want to create a scatter plot. And here's that scatter plot here. It's a very famous scatter plot because what it seems to show is that at the very low ends of GDP per capita increase, so maybe between about 0 and 10K, you have a very steep rise in life expectancy. But then as countries get richer, from like 20K to 50K, most of the low-hanging fruit for improving life expectancy has been used. And you know, humans are not really biologically built to live to 500. So all that extra wealth is not adding a lot to life expectancy. And that's why you have this flattening out of that relationship. Now for the next question, how does life expectancy vary between the different country income groups? Pause the video and think about how you would answer this question with the visualization. So here again, we have a numeric versus a categorical. So we would want to use one of these types of plots. And again, I've chosen to use the mixed violin and jitter plot. And that lets us see that the high income countries, most of them have a pretty high life expectancy. And for the low and middle income countries, it's a bit more of a mix. Finally, how would you visualize the relationship between the continent and the income group? Pause the video and think about this. So in this case, we have 2 categorical type columns. So we'd want to use one of these. And for this, I went ahead to create just a simple stacked bar chart. So from this, you may notice all of the African countries are in the low and middle income category. Then maybe about 8 of the European countries are in the low and middle income category. All the Oceanian countries are in the high income category. But as you can see, there's very few of such countries. So hopefully you found that practice useful for building the intuition around picking specific plots. One final kind of plot that doesn't fit naturally into this categorization I've created here is a time series plot. So let's quickly talk about those. What's a time series? A time series, it sounds like a fancy phrase, but it's simply some value that changes over time. So as an example, here's the Nigerian population over time. I got this from the Gapminder dataset. And usually we visualize these with just bar charts or line charts that have markers on them. So like I said, 2 common ways are bar charts or line charts with markers. So here's how you would plot the data with a bar chart. And line charts are also quite popular for time series. The reason we like to use line charts for time series is that it shows a kind of continuity between the populations. So from the bar chart, one may get the impression that the population jumped from 33 million to 37 million, and then another jump to 41 million, and so on. But the line chart helps to communicate that it's really a continuous increase. Okay, so congrats on getting through this overview of different plot types. Hopefully these examples and practice questions have helped you build foundational intuitions for picking different visualizations. As with everything, practice makes perfect. So keep practicing, keep plotting, and I'll see you in the next video.